Good morning and once again welcome to my YouTube channel Pearson Edexcel International Maths, and in this video I want to explain or introduce to you topic number 1 of Pure Mathematics 1 International Advanced Level. Topic number 9, the very last topic. Sorry for that. I think the topic itself is integration. And when we talk about integration, it sounds something very new, but it is something that you will find you know or you have been doing, but oppositely. If we talk about integrating x raised to power n, we must understand the following, that integration is the reverse, complete reverse of differentiation. So let us talk about what do we get when we differentiate. In differentiation, let us just highlight in our own language what happens. Number one, the original power reduces by 1. Fine. The original index becomes a coefficient. Let's talk about what if we are talking about the opposite, what should happen during integration. The original, the final. The final index becomes not a coefficient, because coefficient multiplies, becomes a divisor. That is complete opposite. The opposite of original is the final. The opposite of coefficient is divisor. Something else. The original power, the final index is reduced by 1. What happens? Here, the final index is added 1 or increases. Is the final index increases or is added 1? Let's just get the opposite, is reduced. Let's just say increases by 1. Something else that you should have noticed during differentiations, any constant die or they are eliminated, and here interestingly a constant is born. So those are basically the three levels of differentiations and integration. So we are simply saying that if we are differentiating, for example, something like if y is equals to something to do with x squared plus 5, then you all know that the differential of this, which is dy dx, is going, this index becomes a multiplant or becomes a coefficient 2x, and the new index is reduced by 1, so x1. This one is a constant, it has died, and that is the differential. If we take this one now, because we know that a differentiation is a way of getting the gradient of a curve, and integration is a way of getting the function back when you have the gradient. So when we integrate 2x, we should be able to get something like x squared. This is the most important part. So if you go further, the symbol of integration is that elongated s. Integrate 2x. Let's now go to the final index becomes a divisor, but the final index is increased by 1. So what are we talking about? If the index is 2x squared over 2, we have increased the index by 1, and that final index has become a divisor. And that's the end of the story. So if you look at this, 2 cancels with 2 to give us x squared. And because we never know what was within that particular function in terms of the constant, then this constant died. We do not bring 5 because during integration we never know what was the constant, but a constant is born. C is the constant of integration. So that is just how we integrate, and I want us to just go to direct to example 1. But before we go to example 1, we must say that if dy dx is equals to x raised to power n, then y, to go back to the function, we have to integrate because we have the gradient. Y is equals to x n plus 1 all over n plus 1 plus a constant c. Of course, n is not equals to -1, because if it is -1, then the denominator the denominator becomes 0, and anything over 0 is infinity. Sometimes we may write the gradient function as f prime x. If f prime x is the x is for n, then the fx, the function itself, now we are going back. This is the reverse of integration, becomes xn plus 1 over n plus 1 plus c, just the same kind of way. And I want in the same kind of video to explain example 1, and this is on page 171. Find y for the following. Find y for 1 dy dx is equals to x raised to power 4. So to go back to y, we must be able to integrate this because we have the differential function and we need to go back to the function. So y becomes x index plus 1, 5 over 5. It becomes the divisor plus c, and that is just like it. When we have something like dy dx is equals to x raised to power minus 5. So y becomes x raised to power minus 5 plus 1 minus 4 over minus 4, the new index, plus c. And that is simply what we have got. So at the end of the day, you must remember that integration is the reverse of differentiation. And most importantly, just remember what we are calling opposite. And because you know the process of differentiation, then the opposite is the process of integration. All right?